Hi everybody. Excuse me, John Walker, your science teacher. And here's my trusty baby Rilo. Okay, so we are going to continue with electricity. Electricity is so important. And those of you that are going to be in construction, and if you choose the path of being an electrician, you have chosen a really good path because that career field is just outstanding. So here we're going to go. We're going to talk a little bit on a couple other things other than voltage and circuitry and things like that. Although everything kind of ties together in this. Electricity occurs in two different forms. Know what that is? Okay. Well, the first form is static electricity. Okay. It's stationary. It's like when you reach out and you touch something and you get that shock. That's static electricity. Okay, you brush your hair and your hair stands on end, and it's because all the different protons and electrons are attracted to each other, or are repelling each other, and that's static electricity. Wool socks in a tumbler dryer. Okay, and then there's current electricity. Current electricity flows around a circuit. We just went through some circuits, didn't we? And then, for example, you turn on a light or a Walkman, and then you have energy. Static electricity occurs with materials which are insulators. Okay, and so static electricity, rubbing adds or removes electrons. And so you get this differential in terms of the number of electrons and on positive and negative, and then when you reach up and touch something, the electrons jump across the field, and they can be shocking. Yes, they can. That's static electricity. An object becomes charged. Like objects repel, unlike objects attract. Electrons flow through a conductor. Conductors are things like in metals, gold, aluminum, copper. We use copper all the time, right? That's a conductor. Negative to positive. Okay, negative to positive. Circuit equals continuous loop for electrons to flow. It needs an energy supply, like a battery. It needs an energy user, like a light. Electrical components, wire, ammeter. That's a way to measure the amount of electricity, in a circuit. Of course, a battery provides electrical power. Fuse. Fuse is used to, if you get too much electricity through a wire, a fuse will break open that connection, and it will stop the flow of electrons. It will stop the flow of electricity. Connected wires, you got to have those wires that connect things together, right? A bulb, a switch, a voltmeter, that measures the amount of volts in a system, very important. Also measures amps. Okay, diode, resistor, rheostat. Simplest type of circuit involves electricity going around, with no choices. Electrons really don't choose, and that's called a series circuit, isn't it? And there it is. There's that simple series circuit. Okay, only one pathway. Okay. The other main type of circuit has two more branches. Okay, and that is what? That's a parallel circuit, right? It's called a parallel circuit. Okay, draw on the electron flow. You can draw where the electrons flow there. You see the yellow line there? Just goes one way. Over here, it goes two ways, right? Okay, so what kind of a circuit is this? A parallel, but more importantly, a short circuit. Okay. Series circuit. Series circuit has a single loop for electrons to travel around. We're kind of going back over some of the things. Components are connected to one another. Current has to travel through all components. Current is the same at all points. Voltage is shared between components. Parallel circuit has two or more paths for electrons to flow down. Current is shared between the branches. Sum of the current is in each branch is equal to the total current. Voltage loss is the same across all components. Okay, current is the flow of electrons around a circuit. That's what current is. It is measured in amperes. Okay. DC is direct current like a battery. Electrons flow in only one direction. AC is alternating current like in the main current that flows in your house or in a business. Okay. Amp meter measures current like we talked about. Unit is an amp. Current is flow of electrons. Connect in series at the point you want to measure. So I'm going to show you an amp meter because I have one. Red to black and black to black. Okay. I'm just going to kind of go through this. Voltage, okay, is the amount of power in a system. Voltmeter measures all that kind of stuff. Okay. Summary. Okay, do you know this? Make sure you do. And that ends this. In the next presentation, we're going to talk about electrical generation. Electricity generation. How is electricity generated? How is it begun and then used? And talk to you soon.